Joining an older enterprise project often feels like stepping into a digital labyrinth. You are immediately faced with thousands of undocumented Java files sprawling everywhere. The standard reaction is to reach for a heavy architecture mapping tool to try and make sense of the mess. Most of these require complex OSGI setups or bulky external binaries just to get off the ground. But these traditional setups have a glaring weakness. If there is a single syntax error anywhere in that massive codebase, the parser crashes entirely. You are left staring at a blank screen and a stack trace. A map is useless if the tool breaks before drawing it. Developers need a resilient cartographer, a system built to survive the reality of broken, imperfect code without collapsing. That is the exact problem code-karta solves. It is a lightweight, purely Java-based mapping tool, engineered specifically to absorb bad code and never crash. It operates on a strict compiler philosophy. Data moves in exactly one direction, stepping through a highly controlled sequence. code-karta uses 3 isolated tiers. Input handles parsing, layout calculates spatial math, and render draws the image. A single data block waits at the top. The golden rule is total isolation. No tier communicates with a tier beside or below it. By isolating these responsibilities into discrete tiers, code-karta ensures that chaos in the source files never derails the final interactive map. The journey begins when raw Java source files are passed via the command line interface into Tier 1, the input parser. The parser is wrapped in a fault-tolerant safety net. When it encounters broken syntax, it logs a warning, skips the error, and continues building a partial map. It also applies automatic noise reduction. Standard library clutter like primitive types, strings, and basic collections are stripped, keeping the focus strictly on unique domain logic. The surviving structure is translated into the graph IR. Messy lines of Java snap together into a clean network of nodes and edges. This agnostic model holds text labels, but its coordinate fields remain completely empty. By distilling a volatile codebase into this bulletproof data structure, Tier 1 establishes a stable, predictable foundation for the heavy mathematical lifting ahead. That graph IR is then passed over the wall to Tier 2, the layout engine. This tier is entirely blind to whether the data came from a simple file or a massive directory. The default simple layout engine uses a breadth-first search to systematically arrange the nodes. It assigns depth levels, placing everything into predictable rows and columns. For massive codebases, the ELK algorithm dynamically bends connecting lines to minimize intersections. Regardless of the algorithm, Tier 2 calculates precise x, y, width, and height coordinates, stamping them onto every node. By isolating all spatial logic into pure mathematical operations, code-karta ensures that structural complexity will never overwhelm the final rendering stage. The spatially aware graph IR now moves into the final isolated tier, the SVG renderer. The renderer follows the math it was handed, transforming stark mathematical nodes into polished UML boxes with colored arrows. The result is a self-contained SVG string, where every element is rigorously tagged with predictable CSS classes. The 3-tier pipeline has finished its work, effectively shielding the fragile rendering process from the chaos of the raw Java source. This pipeline builds the data required to drive the code-karta interactive diagram viewer. As shown in this interface, the resulting map is a functional tool for exploration. Because every element carries stable CSS tags, you can search the map in real time. Unrelated nodes automatically dim to a faint opacity, instantly isolating critical dependencies from the surrounding noise. This interactive layer tames the dreaded hairball problem. It gives developers the leverage to digest and navigate highly coupled systems that would otherwise be visually impenetrable. This single pipeline is flexible enough to generate everything from high-level JPMS module maps down to intricate multi-file stitched call sequences. It can even track complex enum-backed workflow logic, rendering it into clear, readable state transition diagrams. code-karta demonstrates a core engineering principle. Defined architectural boundaries are the secret to turning code-based chaos into a legible system map.